For today's math lesson, we're going to be looking at lesson 14.4 in your Go Math textbook or online in Think Central. Lesson 14.4 is relating multiplication and division. So we already know what two operations we're looking at today. We're either multiplying or dividing. Now, we have to understand what multiplication and division really is. We know that when we multiply numbers, we know that we're increasing in our amount. We're looking for a total. Now, when we divide, we know that we're splitting something up equally. It's a fair share, so splitting them up into groups. Now, when we divide, we're already given the total, and it's being shared out or separated. All right, now, when we talk about relating them together, think back to what you already know about those two operations. Well, we do know that they are inversely related. Now, remember what inversely related means. Inversely related means they undo each other. They are opposite operations. Just like addition and subtraction are inverse operations, multiplication and division are inverse operations. All right, so let's take a look at, we're going to be on page 449, lesson 14.4. Let's unlock this problem here. Pamela, she ordered a set of 6 books written by her favorite author. The set of books, or think of a grouping of books, cost $48. Since she had already read them, Pamela sold 2 of her books to her friend Jody. If every book was the same price, how much did Jody pay? All right, so I boxed in some of those keywords that popped out at me. Now, we could use a strip diagram to help us unlock this question. But before we get to that, what operations will we use to solve the problem? Go back and take a look at those keywords we boxed in. She had a group of 6 books. It cost $48, and she sold 2 of the books to her friend Jody. We need to figure out how much did Jody pay. Well, I know that by looking at my problem, she's not increasing the amount that she paid for those books. She paid $48 for those 6 books. We know that each book costs the same amount. Well, if each book costs the same amount, I'm splitting up that total price equally by those 6 books. So I know I'm going to be using division as an operation. Now, is this a one-step problem? Are we just dividing out our total number of books by that price? No, she then sold 2 of those books to her friend Jody, and Jody paid for those books. Well, if each book costs the same and Jody bought 2 books, we're going to be multiplying for that second step. And if this doesn't make sense yet, we'll get down to that more here. You'll get to see it visually in these strip diagrams. All right, so we circled the numbers we needed to use. We used our cube strategy. Let's go ahead and take a look at our first step. First, we're going to complete our strip diagram to show 48 total being divided up, shared equally, into 6 equal groups. Oh, now I remember when we did equal groups, we're either multiplying or dividing. We ask ourselves, were we already given the total amount? Yes. If we're already given the total amount into equal groups, we're going to be using division. So I'm going to go ahead and write out my division equation up here at the top. 48 total divided up into 6 equal groups, or 48 divided by 6 is some number. Now, if you need a visual to help you out, I have a set of 6 books. Let's say, okay, Pamela had this 6 books and she paid $48 for these 6 books, and they all cost the same amount. So let's divide this up equally. Now our strip diagram shows that our total of this, and this together is 48. I notice that it is in 1, 2, 3, 4, 5, 6 equal groups. Now, we're comfortable using equal groups or a strip diagram to divide this out. I'm going to combine those, meaning I'm going to divide up 48 into these 6 groups, and I'm going to put tally marks. Let's go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. Notice, we split up equally or the same amount for each group. I have 48 tally marks total, which represents the price, divided up into 6 groups representing the 6 books. Now the amount in each strip or each group represents the amount of each book, the price, meaning how much is just this one book? Well, let's take a look. I have 5, 6, 7, 8. And that is the same for the rest of these books, remember, because each book costs the same amount. Oh, so let's go ahead and complete our equation. We have 48 divided by 6 is, how much in each group? 8. So each book, every single one of these books in the set is $8. Now, let's relate what we know about multiplication and division. Meaning, if I already knew that I was dividing 48 divided by 6, I could use my inverse operation. I could use multiplication to help me find this unknown number. Now, this is where we use our fact family triangle. We know our total amount was 48. We know that there was 6 books. Each book cost the same. So we already wrote down 48 divided by 6 is some number. We could also say 48 divided by some number is 6. And we could use our inverse operation to help us out. Well, 6 times something is 48, or something times 6 is 48. Well, think back to our class. We learned this as a rhyme. 6 times 8 is 48. I know a lot of y'all remembered that one. So I could use what I know about these inverse operations, and I could use my fact family to help me figure this out. Because maybe I'm not so comfortable doing this in a strip diagram. Well, draw your fact family triangle out. Use multiplication to help you find that missing number. We got the same thing both ways. So what multiplication sentence can we use to help us solve this problem? Well, 6 times 8 is 48. Now let's think about this. The question is not asking how much is each book. Our question is if each book is the same price, which we now know is $8. If each book is $8, and Jody is buying 2 of those books, how much did Jody pay? So let's complete another strip diagram to show the cost of 2 books. So if you notice, the strip diagram is already into 2 parts, representing book 1 and book 2. Well, I know every book costs $8, so this book is $8. This book is $8. How much did Jody pay for 8 2 times, or 8 plus 8? 16. So Jody paid $16 for the 2 books. All right, let's take a look at another question here. Let's skip around. To number 5 on page 451. directions first. Use the table, use the stimulus for questions 3, 4, and 5. You may use an array, a strip diagram, and an equation to represent and solve. Well, the previous example, we did a strip diagram. For this example, let's do an array. All right. Now remember, an array, that reminds us of multiplication or division because it has a set of objects placed in equal rows and columns. All right, let's analyze the stimulus before we get to that question on number 5. So we have a county fair. We have the price of admission for adults as $6, students as $3, and children 5 and under are free. Okay, so that's really good to know. Now let's talk about that vocabulary word, admission. If you've ever been to a fair, which I'm sure some of you have to pay to get in. Now, that's not the price of doing the games or getting food and all that stuff. It's just to get in. Okay, so admission is just to get in. Let's take a look at this hot question. It's multi-step, more than one step. Jose and Izzy are 8 years old. Okay, before I keep reading, let's think about this. Are they going to fall under the children 5 and under that are free? No, because they're 8. 8 is greater than 5, so that doesn't apply to them. Well, is Jose and Izzy considered an adult? No, because Jose and Izzy are 8 years old. An adult is considered, or an adult is 18 years old. Well, that doesn't pertain to us. Now, are Jose and Izzy students? Is a student somebody that goes to school 8 years old? Yeah. Okay, so the price for them to get in each is $3. Let's just keep that in our brains. And let's keep reading. They go to the fair on a day when all rides are $2. So let's say you get on the Ferris wheel. That's $2. Let's say you go and play a basketball toss game. Well, that's going to be another $2. So they go to the fair when all of the rides are $2 and admission, remember, to get in, is $1 off. Now let's think about this. If it's $1 off, is that going to increase my admission price? Is it going to make it a larger number? Or is it going to make my admission price smaller? Well, if it's $1 off, it's $1 less. Think of this as a sale price. A sale price is cheaper. Now let's go back and look at that again. The admission is $1 off. So instead of $3, $1 less than that is $2. Okay, great. How much will they being Jose and Izzy, 2 people we're talking about here, how much will they pay all together? So we're looking for a total. How much will they pay all together to attend, to go to the fair, and also go on 5 rides each? Now, this has a lot of information. We're talking about the admission, we're talking about rides, we're talking about 2 people. So let's set this up. Now, I said that we were going to do an array, or we could also do a strip diagram. Either way, let's focus on the admission price first. Admission to get in. Let's show that in an array, a set of objects in equal rows and columns. Well, I know that there's Jose, right? I know that there's Izzy. Now, how much does it cost for them to get in? Well, we found that it was $2. Well, is it $2 for both of them combined or $2 for each person to get in? It's $2 for each person to get in. So Jose, the price for him to get in is $2. Well, Izzy, the the price for Izzy to get in is also $2. How many objects do we have here? 1, 2, 3, 4. Or 2 times. Okay, so we know that for the both of them together to get in is $4. But we also want to know about the rides. Now, let's show that in an array also, or we could do a strip diagram. Now, what do we know about rides? Well, we know that there's Jose and Izzy. We know that they do 5 rides each. Okay, Jose is going to do 5 rides. Izzy is going to do 5 rides. Okay, so we're talking about 2 people going on 5 rides each, or 2 5 times. How many objects do I have in this array? Well, we have 10. Now, is 10 representative of my price? No, that's just the combined number of rides those 2 people are going on. So what do we know about the price of the rides? Well, it's not going to be in this it's not going to be in this stimulus. It's going to be back in our word problem. The rides are $2 each. Every ride is $2. Well, I have 10 rides in all. $2 for each ride. Let's show that in a strip diagram. $2 for each ride, and we're doing 10 rides. Well, what's 10 2 times? Well, 10 plus 10, or 10 2 times, is 20. Now, 20 represents the price of the rides. Okay, great. So we found the amount for rides. We found the amount for admission. How do we figure out how much they pay all together to go to the fair that day? Well, we know that all together we're looking for the total amount. We're combining 2 values. So we have $20 plus $4 is $24 for Jose and Izzy to get on 5 rides each, and also get into the fair when the admission price is $1 off. All right, let's do another one together. Oh, before I move on, I do want to mention that we do have a math on the spot video for question number 4. I'll make sure to include that link so you do have additional help on this table question. Okay, let's skip around to page 452, 452. Let's look at number 8, our multi-step word problem, more than one step. But before we get to that, of course, let's read our directions. We're going to fill in the bubble for the correct answer choice. We may use an array, a strip diagram, or an equation to solve. All right, so we've already done an example using arrays as well as strip diagrams. We'll make sure that we do show the equation part as well. Number 8, Paul is in charge of the egg toss at the World Egg Day Fair. There are 48 people participating in teams of 8 people. Now, when I think about this, teams of 8, I'm thinking of groups of 8. Each team, every team needs 1 egg. Well, Paul, he's going to buy eggs in cartons that each have 6 eggs. So think about whenever you go to the grocery store and you buy an egg carton. Now, the egg carton holds the eggs in its little place. The egg cartons that he buys, it holds only 6, and then he needs a new carton. How many cartons does Paul need? All right, and I already know that it's multi-step. And as a 3rd grader, I'm not going to just take these numbers and add or subtract them without reading it, right? I'm going to take it 1 step at a time. Now, that second sentence where it's talking about there's 48 people in groups of 8. I'm going to take care of that part first. Now, whenever we read the rest of the problem, is there more people join in on this fair, on this World Egg Day Fair? Is there more people coming in? No, we already have our total amount of people. We have 48 people and they're in groups of 8. Well, I know that when we're talking about equal groups of something, we're multiplying or dividing. Well, are we multiplying to find our total amount of people? No, we have 48 people in groups of 8, so we're going to divide them out. Or 48 divided by 8 is some number. Well, I could show that in an array, right? I can have groups of 8, and I could put 1 in each group till I get to 48. So go ahead and do that on your own right now. I'm at 24 so far. I haven't got to 48, so I'm going to keep going. All right, so I have my 48 total. I have an array, so I have my people in teams of or groups of 8. Now, what is 48 divided by 8? Well, I can count across. 1, 2, 3, 4, 5, 6. Oh, that makes sense because remember back to our first example with our fact family using our inverse operation? 6 times 8 is 48. Okay, great. Now, what does this 6 represent? There's 48 people total in teams of 8. That means, well, how many teams do I have? I have 6 teams. Okay, each team, which we now know we have 6 teams, each team only needs 1 egg. Okay, well, here's my 6 teams. I'm now using my equal group strategy. Each team needs 1 egg. They need 1, they need 1, they need 1, so on and so forth. Okay, well, how many eggs do they need? 1, 2, 3, 4, 5, 6. So we need 6 eggs for this event. Let's keep reading. Paul is buying eggs in cartons that each have 6 eggs. Well, here's my little carton. Remember, you open it up, and this is where the egg sits on top of so it doesn't roll over and fall around. Well, how many cartons do we need to buy? Well, we figured out we only need 6 eggs. 1, 2, 3, 4, 5, 6. Do we need to go and get another carton? No. We have our 6 eggs. We split that up into the egg carton that holds 6. I only need 1 carton because 6 divided by 6 is 1. So here, our answer choice, our correct answer is A. All right, let's take a look at number 9. Let me erase some of this so it doesn't mess you up. Kat is reading a book with 36 pages. She wants to finish the book in 4 days. How many pages does she need to read each day? Now, go to that keyword of each. I boxed it in. It's important. It's popping out at me. We know if we're talking about how many each day, that's an equal amount every day. Well, what two operations talk about equal amounts? Multiplication or division. Now the question is, are we multiplying or are we dividing? Let's analyze what we know. The book has 36 pages. Whenever we kept reading, did we get another book or are we increasing our amount of pages? No, 36 is our total. So I'm going to put that in my strip diagram as my whole. She wants to finish the book in 4 days. So I'm going to split this up into 4 days. Day 1, day 2, day 3, day 4. Okay, so let's look at our strip diagram. Are we doing 36 4 times? No, we're dividing out equally our number of pages in that book by 4 days. We want to know the amount she reads each day. Okay, so let's use division. Or we could use our inverse operation to help us out. I know that in my fact family triangle, my total goes at the top, and I have a total of 36. And I know that we have 4 days that she wants to finish this in, and we want to know the amount for each day. Now, if I use my inverse operation of multiplication, I'm going to start down here. I'm going to increase my amount to get to my total. I have 4 times something is 36. So maybe you know your 4's facts. So that's a strategy we can use as well. All right, but I have my strip diagram, so I'm going to use this to help me out to solve my missing numbers. So I'm going to put 1 in each group, 1 for each day, till I have no more left to divide out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 30, 31, 32, 33, 34, 35, 36. Okay, I divided out equally my 36 pages by my days. Do I have the same amount for each day? Do I have the same amount in each group? Yes. How many pages for each day? Well, I have 5, 6, 7, 8, 9. So 36 divided by 4 equals 9, or 4 times 9 is 36. Now remember, your trick of 9's on your hands. I can double check myself. So using the trick of 9's on my hands, I can go over 4 times. 1, 2, 3, 4, and I'm going to put that finger down. How many do I have to the left of my bended finger? 3. How many do I have to the right of my bended finger? 1, 2, 3, 4, 5, 6. 36. We checked our work. All right, so Kat will read 9 pages each day. One last one together. Let's take a look at number 10. Let's show this with an equation. Roshan has 18 crackers. He shares the crackers equally. That's a major keyword. He shares the 18 crackers equally with his brother. Then, next, Roshan eats 3 crackers. Think about if you eat those crackers, do you still have them there? No, so we're going to be decreasing our amount of crackers. How many crackers does Roshan have left? Okay. Were we given our total amount of crackers that he started out with? Yes. He has 18. That is my total. He didn't get any more here. His mom didn't say, hey, Roshan, here's more crackers. Increase your amount. He only has 18. Well, he shared those crackers equally with his brother. Well, if you're sharing something equally, and we said he's not getting any more crackers, what operation are we going to use? Well, I'm going to separate those 18 crackers between me and my brother. 1 for me, 1 for you, 1 for me, 1 for you, right? Until I have no more crackers left. What operation is that? Division. So I'm going to divide it between me and my brother, 2 people. 18 divided by 2 is some number. Well, I can use my inverse operation to help me solve this. 18 divided by 2, or 2 times what is 18? Well, I can count by 2s till I get to 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. How much is that? 9. Oh, okay. Well, I notice that 9 is an answer choice. Have we answered the question all the way? How many crackers does he have left? No, we're missing a step, so do not stop here, right? 9 just represents how much each of us get. But then Roshan, right, he has 9. He got 9. He eats 3 crackers, and we want to know how much does he have left. Okay, so let's say I have my 9 crackers, and I ate 3 of them. They're gone. Well, I'm going to subtract the total minus the 3 that I ate. How much do I have now? 9 minus 3? 6. I have 6 crackers left. All right, guys, so today we related multiplication and division with a strip diagram, our part whole map. We also did that with an array where we had our set of objects placed in equal rows and columns, and we also showed that in an equation. Now, independently on your own, for the rest of these questions, if you'll solve the rest of these 1 or 2-step problems that involve multiplication and division. If you have any questions, let me know. Bye, y'all have a good day.